Beneath the shadows of Geneva, far below the world's surface, lies a stunning achievement of human innovation and an inevitable harbinger of devastation, the Large Hadron Collider, LHC. It stands as a marvel of intelligent analysis, allowing scientists to probe the subatomic realm and triggering the discovery of the elusive Higgs boson, often dubbed the God particle. This breakthrough has captivated the scientific world. Yet, as renowned physicist Brian Cox once ominously declared, a hidden potential has been uncovered at CERN, sparking a wave of curiosity and concern. Could our pursuit of knowledge have led us down a dangerous path? Have we set our course for an uncertain future, possibly one that defies our understanding? Before we dive into the statement, it's far more persuasive to sort out what molecular gasoline pedals are. The Large Hadron Collider, LHC, operated by CERN, is a 17M ring of superconducting magnets. In addition, it's the world's most prominent and most noteworthy atom smasher. It represents the pinnacle of human achievement. As a matter of fact, it's so powerful that it could reproduce the precise states of the first moment on Earth. But could the system intended to unlock the mysteries of the universe hold the key to something truly specific? Founded in 1954, CERN is one of the world's most famous research institutions. With 23 member states and countless researchers, it's a place for collaboration and innovation. The LHC is CERN's principal undertaking, but it is only one part of a large organization of gas pedals and tests. Consider a route not for automobiles or people, but for subatomic debris. In a trial of aptitude, patience, and space itself, the LHC accelerates protons to almost the speed of light, sending them on a collision course that reflects the energy of the universe right after the Big Bang. The impacts create temperatures much hotter than the core of the Sun. A vast number of magnets guide the protons on their journey, while complex cooling structures keep the magnets at temperatures colder than space. The beams in the LHC are made to crash at 4 locations around the gas pedal ring, connecting with the spots of 4 particle detectors: Atlas, CMS, ALICE, and LHCb. Each detector serves a specific purpose, investigating different components of particle physics. Together, they act as large cameras taking pictures of these collisions. Scientists then sift through the debris, searching for signs of the elusive Higgs boson, also referred to as the God particle, and other anomalies that could provide clues about the universe's essential building blocks. By focusing on the microcosm, we gain insights into the universe. But with every solution comes another question. With every discovery, another challenge emerges. The LHC is not just a scientific instrument, it's an exhibit of human curiosity and progress. It represents our entrepreneurial mission for knowledge and our desire to understand the key forces that shape our universe. But as we push the limits of what we know, we must also consider the more profound and existential questions that arise. What are the risks of probing the unknown? Could our quest for knowledge inadvertently unleash powers we have no control over? A shocking revelation within the sacred halls of CERN, where the boundaries of human knowledge are constantly pushed. A revelation has arisen, one that sends a shiver down the spine of even the most pro-science thinkers. Brian Cox, a former scientist at CERN and an expert in particle physics, recently said something that left the world both enthralled and uncomfortable. Cox's words resound with chilling clarity. The purpose of CERN's Large Hadron Collider is to recreate a mini Big Bang. Yes, you heard that right, a small version of the very event that gave birth to our universe. The physicist also went on to explain the ramifications of this aim, highlighting the LHC's immense potential for making new discoveries. This includes its ability to uncover the secrets of the Higgs boson and explore dark matter, a mysterious substance that makes up a vast portion of the universe. Imagine holding the power of creation in your hands, the capacity to summon the very essence of the universe. It's an attractive possibility, but one fraught with danger. The mini Big Bang, power and responsibility. The mini Big Bang isn't just a theoretical concept, it's a very real phenomenon within the LHC. The temperatures, pressures, and raw energy produced inside this machine recreate the exact conditions of the universe's birth. It's like standing at the dawn of recorded history, witnessing the genesis of existence itself. Yet with such power comes responsibility, and the question looms, what if something goes wrong? In fact, something did go wrong, not in CERN, but in a different part of the world. A tragic incident in 1978, the proton beam disaster. In 1978, Russian physicist Anatoly Bugorsky experienced an event that would forever change his life. While working on the U-70 synchrotron at the Institute for High Energy Physics in Prodvino, Russia, a failure in the system caused his head to accidentally enter the direct path of a proton beam. The beam, carrying an unimaginable force, pierced through his skull, entering through the back of his head and exiting through his nose. What happened next was terrifying, yet miraculous. Bugorsky recalled seeing a flash brighter than 1,000 suns, but he felt no immediate pain. However, the beam's path left a trail of destruction inside his body. Burning tissue and bone, despite this, he remained conscious and even walked to the medical center for treatment. The outcome was both troubling and remarkable. The proton beam had caused localized tissue damage, leading to hearing loss in one ear and partial facial paralysis. However, his cognitive abilities remained intact, and he continued his scientific career. This incident serves as a chilling reminder of the immense power and potential dangers of particle accelerators. The darker side of the LHC: are we playing with fire? The dangers of a particle smasher like the LHC are not to be underestimated. The potential for catastrophic reactions, the risk of altering the very fabric of existence. These concerns are not just science fiction, they are real questions posed by respected scientists. One of the most unsettling and captivating fears surrounding the LHC is the possibility of creating a miniature black hole. Black holes, a theoretical nightmare. Black holes are regions of spacetime where gravity is so strong that not even light can escape. They are the devourers of stars, vacuum cleaners of the universe, and enigmatic entities lurking in the cosmic shadows. The fact that the LHC could potentially create such a phenomenon, even on a microscopic scale, is both awe-inspiring and terrifying. Could this black hole eventually grow out of control, swallowing the Earth from within? Scientists at CERN have repeatedly reassured the public that any black hole created would be unstable and disappear rapidly. Still, the mere possibility has sparked debates, ignited fears, and left humanity in awe of the energy we wield. But how could the LHC create a black hole? It all comes down to basic mechanics. When protons are smashed together at nearly the speed of light, the energy produced is so immense that it distorts the fabric of spacetime itself. Imagine a trampoline stretched tight. Now drop a heavy object onto it. The fabric bends, and if the object is heavy enough, it could create a deep well that pulls everything nearby into it. This is an analogy for what could happen inside the LHC. The role of extra dimensions. In the realm of quantum physics, where the laws of the universe are both strange and wondrous, there is speculation that extra dimensions might be hidden within our reality. If these dimensions exist, the LHC's experiments could tap into them, creating a gravitational well that forms a small black hole. Even the legendary Stephen Hawking addressed this possibility in his book. He warned of a scenario where the Higgs boson could become unstable at very high energy levels. This instability could trigger a catastrophic event known as vacuum decay, an event that wouldn't just destroy Earth, but could potentially annihilate the entire universe. The unsettling words of Sir Martin Rees. Renowned English cosmologist and astrophysicist Sir Martin Rees also expressed concerns about the experiments at CERN. In his book on the future, Prospects for Humanity, he explored the potential dangers of particle smasher experiments, including those at CERN. His words weren't just cautious, they were filled with a sense of existential dread. Rees examined a worst-case scenario in which a failed experiment could trigger a phase transition that would ripple through the fabric of space-time, resulting in a cosmic disaster. While he assigned a low probability to such catastrophic outcomes, he argued that even a small chance warrants serious attention. The stakes are high, and the margin for error is razor-thin. The precautions at CERN: are we safe? The scientists at CERN have run simulations, analyzed theories, and taken every precaution to ensure the safety of the LHC. Even Brian Cox himself acknowledged the inevitable concerns and questions surrounding the LHC's activities. He reassured the public that, 1. There are rigorous safety protocols in place. 2. Thorough reviews and procedures ensure the LHC operates with the highest level of detail. 3. The energies involved are well within what Earth naturally experiences. 4. The chances of creating a stable black hole are astronomically low. Even if one were created, scientists say it would be so tiny and volatile that it would deplete rapidly in an explosion of energy, a phenomenon predicted by Stephen Hawking known as Hawking radiation. It would be a fleeting moment of cosmic wonder, just a brief glimpse into the void, and then gone. Are we opening a door to another universe? Some have taken the idea even further, speculating that the LHC's experiments could open a gateway to another universe or even to another dimension. While this idea is dismissed by mainstream scientists, it has captivated the imagination of many. What lies beyond our universe? Could we accidentally unleash forces we don't understand? The idea of opening a door to hell has been sensationalized in various media, fanning the flames of uncertainty. Conclusion: the future of the LHC. The Large Hadron Collider represents the zenith of scientific endeavor. While there are certainly risks, they are measured and mitigated by rigorous scientific protocols. As we continue exploring the deepest mysteries of the universe, we are reminded that our quest for knowledge, though fraught with uncertainty, is one of the driving forces behind scientific progress and the evolution of humanity itself.
The latest from CERN, Brian Cox discusses the unexpected discoveries.